Welcome to Unit 3 of Advanced Six Sigma Black Belt. We're going to cover a little bit on lean manufacturing and also start getting into SPC, Statistical Process Control. These are the lean methods or the waste elimination that we're going to cover. I'm not going to spend much time on these. The best way to learn this is just go to YouTube and Google. In fact, I was tempted not to put a reading list with the videos on it. But go ahead, see what you got. I'll admit I didn't spend much time on it because long after this course is over, if you ever want to know about 5S, let's say, just Google 5S and see what comes up. Don't come back here and try to get it from this or memory. Now, when I was in the Army, we all had uniforms, and when we wore that uniforms, it was just that, it was uniform. I knew where the ammo kit was, the water, the ammunition. The reason we all had the same place is if we were in the battlefield, and let's say I ran out of ammunition, I could go to the guy next to me and just, if he was dead or wounded, grab his ammo pouch, because I knew exactly where it was. Same thing in industry. You want to put everything in the same place. Think about many times you look for that tool or those parts that weren't where they're supposed to be. As a side note, 5S works very good in group situations. There's a study that found that if you're not in a group, 5S is a waste of time, actually. There's no benefit to one guy organizes his desk if he's the only one at that desk. Let him do it himself. Pogi-yoke is a Japanese term. It means mistake proofing. This is where you have to retype your password, or you design a part that to fit in only one way, so you can't get it backwards. I even use this at home. I dangle a string from the garage ceiling, so my wife pulls in the car. When the tennis ball bumps into the windshield, she knows she's in far enough. Her old method was to basically use the back wall, just run into that thing, and then she knew she was done. Much better system. Standard work. If you watch people do the same task, you'd be amazed at the variety of ways of doing that. What standard work is about doing the same task the same way by whoever does it. This goes way back to when Frederick Taylor did his time motion studies. He'd actually film somebody typing, the best typist, and make everybody type that way. Key to this is tact time. You got to get that standard work, but you got to meet your tact time. In other words, your customer demand, the pace. Very important to do it the same way, no matter who's doing it. It eliminates variation from piece to piece, shift to shift, worker to worker. When you buy a book online now, the book doesn't actually exist. It's not even printed until the order is there. What Kanban pull is you don't keep inventory. You only make it when the customer pulls it out of you, wants it out of you. A good example is like go to the grocery store and watch how they stock dairy milk cartons. They're all stocked from the back and they're on a inclined shelf. So they don't actually stock the milk until there's a space in the back, and that keeps the proper amount of inventory, and none of the milk goes bad because first in, first out. So what you want to do is wait till the customer pulls it, and then you supply it. Cycle time is the amount of time it takes to complete a task, and then just move that whatever it is you're doing through the process. And you do this through all these other lean tools. It's very important that you meet the tact time, like we were talking about earlier. Cycle time reduction, critical to customer pleasing the customer. Continuous flow. This is about reducing the batches. Traditionally, manufacturers did things in clumps, big batches, like baking cookies. Continuous flow is basically one piece flow. Make one piece at a time and keep on rocking with it. I'm actually going to make a video. I couldn't find one like I really liked, so I'm going to make a video on this. That'll explain a little bit better, I hope. Back in the old days, the automotive industry would take about 2 weeks to change over lines from one model year to the next. So basically the factory shut down for 2 weeks. Nowadays, is practically invisible. You can't tell the difference between this year's model and next year's model. It just happens seamlessly. Um, by 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 just looking at it, you can tell that this is not value added. The customer's not going to pay for long setup times. They're paying for the product or service. So the best thing to do is get rid of it, reduce your setup times as much as possible. Well, it's beyond the scope of this class, but we always made it into a project, a news Microsoft project. We focus on the critical path. Reduce that, we reduce our cycle times. Very, very, very important. I know of one company that saves $14 million a year just by reducing their setup times and attacking it. Quick response manufacturing. This is a new concept, fairly new concept, coming out of University of Wisconsin. And the thing is that they're going to focus on lead times, right? Reducing lead times. An extreme example would be the International Space Station now has a 3D printer on board. Where they used to have to wait for parts and stuff to be rocketed up there. Could be 2-3 months, right? Nowadays, they just send up the electronic files and print them off as they need it. Lead times have been effectively reduced down to however long it takes to print that piece they need. Quick response manufacturing, reducing lead times. Kaizen comes from two Japanese words, Kai, change, Zen, good. And what this is basically a term that you use if you're going to improve productivity, quality, reduce inventory, or just make any improvements to the entire system. There's a couple types. There's continuous improvement, where you just make the changes as they come along. Or if you're going to make a major change, you might have what's called a Kaizen blitz. You come there and just do a major overhaul of the entire work cell system or whatever. Kaizen. In 1986, a guy named Goldratt wrote a book called The Goal, and in it he basically said that in a process there's something that's going to be a bottleneck or a constraint that they'll control the pace of your output. What theory of constraints is you focus on three big things here, that being the throughput, control of your inventory, and how much it costs you, right? And you got to work on that to get that throughput through, reduce inventory, and reduce cost. This drum buffer rope is kind of a new concept. There are some constraints that you just can't change. They're going to go as fast as they can. And that's going to control the beat or the drum. Think of takt time here. This is how fast it's going to output. Now you want to keep that going at full speed. That's your constraint. Got to keep it going full speed. And although you don't like work in process, the buffer is basically the whip that feeds the drum. You want to keep that stocked enough so the drum doesn't have to wait for the inventory to go into it, the inputs to go into it. All right, and the rope actually goes one step above the buffer, and basically that goes back to the pull system. You can go, even though you got the constraint, you're going to try to go back to the pull system, the Kanban system that we had. So that's the drum buffer rope. And how it applies to theory of constraints. Keep the bottleneck, keep the constraint going at full capacity as fast as it can. Overall equipment effectiveness. This is where you take your equipment and how well is it performing? How well is it delivering what you want to deliver? There are three components to this. One is availability. Is the equipment available to work? Productivity, is it running at the speed it's supposed to run? And quality, is it producing the quality that you need? Now you take these three things, you couple them together, and that'll give you your overall equipment effectiveness, or OEE. And you got to multiply them together. That's a coupling function. You just can't add them. Very effective. World class is actually only about 85% OEE. But I'll have some links in the discussion on this. So we're in the C part of the DMAIC Six Sigma roadmap controls. And we're going to talk about statistical process control very briefly here, but there'll be quite a bit on the PowerPoints and videos. Walter Stewart started this May 16th, I think, in 1924. And what he did is he said all things vary. So you got to measure that variation, then control it. and it's been around since, and what's that, almost 100 years, right? And it's very much process oriented, with the thought being that if we have a robust, controlled process, the product or service will naturally come out okay. And it's real time, right? One of the biggest failures of this is they don't do SPC in real time. They do it after the fact. I don't know if you ever tried to fix a problem that happened 2 years ago, right? Same thing. And you also use this for process improvement, so it can be used throughout the DMAIC process improvement. Where do I need to improve? Is process control again? You want to make sure the process is robust. You want to measure the process. And this will help you pinpoint where the variation in processes are. And that's where you want to focus your attention as black belts. SPC. Again, this is all I'm going to talk about it here in the PowerPoint. But there's quite a bit on videos. I'll give you a handout that I use to teach the one-day course. Oh, that's the other thing I want to talk about. It's very important that the people that do SPC for you on the floor understand why they're doing it, how they're doing it, and what's in it for them. That's ultimately who it's for. It's for the people who have control of the process.